Hi everyone, Lior here with another Jumpstart Lightning episode. I have Francisco with me to continue the conversation on AKS Edge Essentials with everyone's favorite topic, networking. Stay tuned. Hi everyone, Lior here, another Jumpstart Lightning episode. And again, I have Francisco with me. Francisco, how are you doing, my friend?
I'm doing great. How are you doing, Lior?
I'm doing awesome. I'm excited to continue to have this conversation with you about AKS Edge Essentials. And Francisco, before we dive into the fascinating world of Kubernetes networking and specifically with AKS Edge Essentials, who you are, what is it that you do?
Yeah, my name is Francisco Cabrera. I'm a technical program manager here at the Azure Edge team, specifically working on AKS Edge Essentials.
Francisco, in the previous episode, when we kicked off this series, we had a conversation about what AKS Edge Essentials is all about. We talked about the use cases and all those good stuff. So before we have this conversation about networking, which is a very popular topic, we get a lot of questions regarding that. Let's do a quick recap on the overarching architecture for AKS Edge Essentials.
Sure, let's go ahead. So here you can see this diagram, right? This architecture diagram. We're going to do it from bottom all the way to the top, right? So in the first layer you have the hardware layer, right? Well, AKS Edge Essential is targeted for these kind of PC class hardware devices, and we're talking about these kind of Intel NUCs, i5, i7, 8 GB of RAM, 16 GB of RAM. And on top of that, right, we need a Windows host OS, and that Windows host OS can be Windows 10, Windows 11, Server 2019, or Server 2022. AKS Edge Essentials, right, sit on top of that Windows host, and basically you can run both a Linux node or a Windows node. The Windows node is optional. So in this diagram, right, on the left hand, right, we have our Linux node, which is currently it's a VM based on CBL Mariner, right? CBL Mariner is our own Linux distribution at Microsoft. And this node can be a Linux worker, right, or a control plane, both for KDS or K3S. And here's where you would run your Linux containers, right? Or any kind of Azure container like Arc or like Flux, right? And then on the right-hand side of the diagram, you have the Windows VM, right? Again, this is optional. And this is, we're running this Windows VM so that you can run Windows containers, and this will act as a Windows worker, both KAS or K3S, right?
Yeah. So, Francisco, today we're going to talk about single machine deployment. We'll talk about multi-machine deployment in a cluster. And this world of networking, I gotta ask you here maybe a question and maybe share with you an observation. Obviously, you and I, we talk to a lot of people that are in this space of Kubernetes, and it's not enough that Kubernetes by itself can be complex. It has a lot of moving parts. It's not sometimes it's not the most intuitive thing, and now you're adding networking on top of that, which is always a topic that, if you're not coming from that background, sometimes it's hard to connect the dots. So that's why we wanted to have this conversation today and start diving deep into the world of networking, specifically with AKS Edge Essentials.
Yeah, sure. I was just saying, networking is really complex, right? We're trying to make it really simple, right? And, the purpose of, of this talk is just like, let's go and deep dive on different kind of networkings that we have, right? The different deployment types and what we're doing for each of these deployment type and how we're fixing, right, the whole networking stack.
All right, let's do this.
So yeah, let's maybe start right with our what we call a single machine cluster, right? Which is like kind of, let's call our simplest way of deploying Kubernetes, AKS Edge Essentials. And as you can see here, right, this diagram is basically we're showing a single machine cluster that is using an internal virtual switch network architecture. So, the diagram is quite similar as we were seeing in the past. So we have a Windows host OS, right? It has a Linux Mariner VM for running, as the Linux node. It has a Windows VM, right, for the Windows worker node. And then in order to communicate, right, all these pieces, we're using a Hyper-V internal virtual switch, right, which is the box here in black.
Yeah.
So basically what we do is when you deploy, right, AKS Edge Essentials and you say, I want to use a single machine cluster, we will create that internal virtual switch for you, right? And we will create all the networking kind of setups for you. And that means, right, we're going to create the network adapters, right? And we're going to set up, the IP addresses. So if you can see here, you're always going to have, the host OS. We're always going to have the 192.168.0.1. the Linux node will always have the 0.2, right? And then the Windows VM will always have the 0.3 kind of addresses.
Mhm.
The other thing that you can see here in this diagram, right, is that if you want to go right to the external network, we have a NAT there, right? So we're NATing all our traffic so that you can go outside, you can have both inbound and outbound connections, right?
And behind the scene, right, Francisco, like just from my familiarity with Hyper-V universe and how netting is being done, this is basically MAC spoofing, right?
Correct. Yeah.
Okay.
So yeah, just let me just two more things that I would like to add. The first one that we're getting a lot of questions is like, hey, can I SSH into the machine? And the question is yes, but there's some specific things here. When you're doing when you're on the Windows host, right, the SSH connection, right, to these VMs are done through a Hyper-V socket. This is a special kind of socket that can only be created between a host OS and a guest OS. So that's much more secure than doing SSH over normal TCP.
Of course.
Also, that means, right, that if you want to access, if you want to do SSH right from an external device or something like that, you won't be able to do it, right, because you won't be able to kind of create that Hyper-V socket.
Okay.
And then the other question that we get a lot with these kind of internal switch deployments is what I can do in order to expose, right, one service to the kind of for external devices. So when you're doing that, basically you have two options. The first option is, using the network shell, the netsh command at Windows that will allow you to do port forwarding. So basically you will forward all the incoming connections right on the host OS, and you will forward that to whatever service IP you got. And the second one, which will lead into our next slide, is you can create a scalable cluster, but using an external virtual switch, but just leave it to one node, right? Do not scale it for 2 or 3 devices. You just keep it for one device.
And Francisco, as you are transitioning to the multi-machine deployment method and the architecture there, this reverse proxy thing, it's kind of a common practice, especially for folks that are in the business of working with Kubernetes CLI, kubectl against clusters. It's a thing that is already out there. It's not like we are reinventing the wheel here in any way, in the sense of reverse proxy for Kubernetes authentication, or I should say Kubernetes traffic or interaction with the cluster, right?
Yeah, correct. Yeah, and we do provide some kind of configuration, right, during deployment in order to support these kind of scenarios.
Okay, cool. All right. So Francisco, that was a single machine deployment, but we all know that a lot of the time in production environments, a cluster will have multiple either physical or virtual machines that are assembling the cluster, basically multi-machine cluster. How does that look like from a network architecture standpoint?
Yeah, sure. So let's go to the next slide, right? Where we're talking now here of what we call a scalable cluster, right?
Yeah.
And if you can see these diagrams, a bit more complex, right? So now instead of having one device, right, we have 2 devices, right?
Yeah.
But in a sense, it's kind of similar. So what we do here, right? Because the different nodes need to communicate, right, between each other. So then that means that these nodes need to be on the same network. They need to be on the same external network. So what we're doing here, instead of using an internal virtual switch and a NAT, we basically use an external virtual switch. That means that all the different nodes are connected directly, right, to the external network. So if you can see here on the left-hand side, right, you have the node device number 1, and you have a physical network adapter, and on top of that, we will create this kind of a virtual Ethernet network adapter. And then for each of the different nodes, we'll also create the different network adapters. One difference between single machine and scalable cluster is that here you need to set the static IPs, right? If you remember, for single machine, we were setting all these IPs for you, but here you'll have to set that as part of the kind of the deployment JSON that you need to create.
Yeah, pretty cool. Pretty cool, Francisco. Just let me ask you a question here, or maybe more of an observation for people that wants to use this multi-machine deployment. They don't need, so let's just emphasize something. They don't need to worry about network address translation because you're already living on the external switch, which connects to the external fabric, right? That's why you don't have that network address translation here, right?
Yeah, that's correct, right? Basically, these nodes are connected directly to the external network, and they're going to be reachable on the external network.
Okay.
Cool. So yeah, as you can see here, right, device number 2 on the right, you can see right the same. So what you have your virtual network adapter for the host OS, right, and then you have the network adapter, for the Linux VM with this IP address that we're setting, and then you have the Windows right VM with another network adapter. So yeah, that's kind of basically the networking aspect when we're doing external virtual switch on scalable clusters. So now let me just recap all what we're seeing, right? Just like let's go ahead and do a comparison between single machine clusters and scalable clusters.
All right, that's a good table. Yeah, let's go over that.
Yes. So let's go ahead. So we already talked about the type of virtual switch. When we do single machine, that's an internal virtual switch. Scalable cluster, we're doing external. Virtual switch creation, right? Single machine, there's nothing you need to do. We will create that switch for you. And then for the scalable cluster, we'll create a virtual switch. We just need to you to set up, what's the net adapter name, what's the physical adapter that you want to use.
Okay.
IP address assignment, again, single machine, all the addresses are defined. 01 is the host, 02 Linux node, 03 Windows node. When it comes for static IP, when it comes to scalable clusters, you'll have to set up all the IPs for you. You have to put that on the deployment. Outbound connections, we just talked about this. Using NAT when using single machine, scalable cluster, that's part of the, you will connect directly to a physical net adapter. Inbound connections, single machine, that's an internal network, right? So it's not reachable. Scalable cluster, you just use the node IP address. Network plugins is the same. So for KDS, we support Calico. For K3S, we support Flannel. DNS, this is configurable. So basically, if you do not provide a DNS servers, what we're doing during our kind of deployment is we'll grab the, the Windows host DNS servers and we'll just put that to the VM.
Yep.
Proxy, as I was telling you, also configurable. You can set the HTTP proxy, the HTTPS proxy, and also the no proxy variables. Offline deployments available for both. Then we have the service IP range, right? So if you're doing single machine, you only need to define what's the range size. So basically say I want 10 IPs. And that's always going to start on the 192.168.0.4. When you're doing scalable cluster, you basically need to say, hey, this is going to be my starting address, right? The service IP range start. And you get this size also. And finally, static MAC address available for both. You can just set up, the MAC address you want, and network NTU also available for both.
Okay, so a very good table to recap everything. This is Jumpstart Lightning for Cisco. I know that you have a demo to show me to just kind of see how everything plays in action. Let's see how things looks like behind the scenes.
Sure. So I've already set up. Let me just 1 second. I already set up, a cluster here. I have a 3-machine cluster. But let me first start by just going over our kind of deploy template that we use for our first kind of device. So if you can see here, right, we have the deployment type. It's a scalable cluster, as I was telling you. Service IP range start, I'm going on the 161, and the range size is 10. I'm going to connect it to ARC. Network plugin, we're using K3S cluster, so we're using Flannel, right? The gateway address, it's my home, right, gateway address, so it's 50.1. Prefix names 24. DNS service, I'll just put in here the same as as your machine, my machine. We're not going to be using proxy, unless here is important things, right? So the adapter name, right, the physical adapter name is called Ethernet, right? And I have 2 nodes, right? And in these machines, I'll have a Linux node, which is going to get the 5156, and I'm going to have a Windows node, which is going to get the 5157, right? So this is the JSON file that you provide during deployment type, and this will grab all those configurations and create all the VMs for you.
Okay.
So now let me go here, right? Let me open here PowerShell, and I can do kubectl, get nodes. And if you can see here, this is machine. My machine here is called the VBox. So we have a Linux Edge and a VBox Windows Edge, and also the other kind of nodes in my other machines. So if I can go do kubectl, describe node, and I do VBox Ledge, right? And if I go to the IP address, I'm going to see, right, of course, the 50.156, right, which was the one that I provided. I can go ahead and do the same, right, with the Windows Edge, right? And I should be see the 157, which you can see here, right?
Yeah, which is super cool. Like it sits inside, like it's in the same cluster. I mean, I know that, this sounds like, yeah, sure. I mean, Kubernetes, multiple nodes, But we're talking about the deployment that is not being managed in the same way that we're managing AKS clusters in Azure, right? When you have like all these end-to-end control and all of that. This is like, these are clusters that are designed to be deployed outside of Azure, but being managed by us. So I really dig the fact that we kind of thought all these components and everything that's got to do with the networking stack and also the JSON that doing a pretty good job in describing how that looked like. And now that you're making me this mental connection between, okay, we saw what we had in the JSON, this is what's happening, after the cluster is deployed.
Yeah, sure. And as you were saying, it's really easy. It's really declarative. Just like, hey, I want these IPs, I want this DNS, and we'll handle it all for you, right? Yeah. The other thing, maybe I want to show you here is that we were talking about SSH, right? How I can check things inside a VM. So, one option, right, that we have this invoke AKS Edge node command, where we're gonna say I'm gonna invoke a command inside my Linux node, and I'm gonna say my command is just, let's go ahead and check that actually inside the VM, if I do IF config, right, the IP is the 156, so I'm gonna do IF config, right. This is going to be running inside the Linux node and provide, right, the response back to PowerShell. So this is all the output of IF config. And if you see here, I have the Ethernet 0 inside the VM, which is using the 150, the 50.
And just to emphasize something here, right? This is not something that is accessible from the outside universe, right? The 192, 168, 50, 156 that we're seeing right now on the screen, this is an internal private IP that is assigned to that node, not accessible from the outside. I mean, it's accessible from your network, obviously, but not from the outside world. So just kind of not to be confused with, with Kubernetes services that and ingress controllers that are exposing services that, connect to the actual nodes and the application on the nodes, right?
Yeah, correct. Yeah, we're talking about our external network, right? Like my private external network, right? My router network. We're not talking about public internet here, right?
Yeah. Okay.
So that's pretty cool. I can go ahead and do the same, right, with Windows, right? So if I do Windows and I do command, right, IP config this case, right, it's Windows, right, and here you go, right. So we have the Ethernet, the 157.
Yeah.
So just the last thing I want to show you is like how we scale these clusters. I was telling you, right, I was it was a single. It was this was my first kind of machine, 2 nodes, and now if I want to do a second machine, right, so basically what you do, right, is it's pretty simple. You go to your first machine, you get this kind of a scale config template, which basically what we do is it will kind of get all the information you need to join the cluster. So if you see here, it's going to say the scalable cluster, right? I'm going to join, right? This is the join token, right? This has all the information, which is a control plane IP, what's a network plugin, all the networking is already there for you. The only thing that you need to do is what are the nodes that you want to do here, right? And specific, this was a new machine, so you'll have to put the adapter name. Maybe it's called the same, maybe not, right? And you will say, hey, I want a Linux node with this new IP, and I want a Windows node with this new other IP, right? Then you just go ahead, you deploy using this other new JSON, right? And this ends, right, with this kind of deployment where you just have two devices with 2 Windows nodes and 2 Linux nodes, right? And then you have another device with a Linux node.
And that's what I wanted to emphasize as you were walking through this JSON. We talked about in the architecture diagram of the scalable cluster, we talked about this notion of multiple devices. So again, just to amplify that point, we're talking about 2 physical devices, right, that has nodes deployed inside those devices, and basically everything is connected to the same control plane of Kubernetes, and you're just describing the scalable effort, like the scale effort to add those physical machines and the nodes that are deployed or that will be deployed inside those physical machines.
Correct. Yeah, and as you can see here, right, this is 3 control planes, so this is kind of would be like H from that perspective, right?
Yeah. Okay. Super sweet. Francisco, this was a great episode. I mean, at the end of the day, networking is really the foundation. Everything runs on network. You need to understand the fabric. And in future episode, we're also going to have an episode on the storage elements, the upgrades, and everything in between. So for the Jumpstart audience, make sure like, subscribe, follow this series, because you see the level of details that we're coming up with. Also, let us know if you have any questions in the comments down below. Francisco, I wanted to say thank you for joining me to yet another awesome episode around AKS Edge Essentials.
Yeah, thank you for your time, and looking forward to our next episode.
Thank you, everyone, and we're going to see you next time.